in my second lecture on grams of diffusion, I have already discussed about the grams of diffusion in my last lecture L1, and lecture 2 just I am going to explain some questions which are going to be asked in case of IIT. Some questions are going to be explained without actually, most of the students are feeling the part of application of the questions. They have no idea, they have very good idea on the concept, but they are unable to attack on the questions. So it is very important to actually how should they should attack on the question by keeping the concept of a particular thing in our science. It's a question, a composition of the equilibrium mixtures Cl2, its molecular form in Cl attained at 12 degrees 100 degrees Celsius is determined by measuring the rate of diffusion through a pinhole. It is observed that at 1.88 mm mercury pressure, a mixture diffuses 1.16 times as fast as that of krypton under the same condition. Then we have to calculate up to what fraction of Cl2 molecule is going to be dissociated in case of actually in case of chlorine atom. Just इसको erase यहाँ से हो जाएगा ना ये
प्लीज कर लीजिए आप
ये
नहीं रिलीज करना है
हाँ
पेज बढ़ा लीजिए
ये
हाँ एक और बढ़ा दीजिए पेज पीछे जाएंगे
अच्छा
एक और कर लीजिए
अच्छा it's a container. Cl2 is here. It is going to dissociate into two Cl atoms. Both are in gaseous state, and there is a hole. Across the hole, the mixture is going to come out. ये क्या था? R mixture is equal to 1.16 times that of R of krypton. This means rate of diffusion of mixture by rate of diffusion of krypton is equal to 1.16 times root under 84 by molecular mass of mixture. It's the first equation from the Gram's law. Second one, mixture में है क्या देखो, this Cl2 is going to dissociate into 2 moles of atom of Cl. At initial state, T is 0. If there is 1 mole, there is no mole of Cl, it was 0. After time T, 1 minus alpha. Alpha is the extent of dissociation which has to be calculated, and is 2 alpha. Total number of moles at equilibrium one minus alpha plus 2 alpha is equal to 1 plus alpha. Just now we have to actually decide the fate of this mixture. From this expression, 1.16 square is equal to 84 by molar mass of the mixture. Molar mass of mixture is equal to 84 whole divided by 1.16 का whole square. From this relation we have got what may be the molar mass of the mixture from here. Now we have to calculate the value of this molar mass of mixture from this expression. Come to this. Cl2 was there and 2 moles of atom was there. T was 0, 1, 0. At T, 1 minus alpha, it is 2 alpha. Now this molar mass of mixture is equal to Cl2. So 1 minus alpha into 71, it is the molar mass of this Cl2 in the mixture, plus 2 alpha into 35.5 the molar mass of the actual chlorine atom in case of the mixture. Now in case of the 1 plus alpha is total moles. The 71 minus 71 alpha plus 71 alpha by 1 plus alpha, it must be equal to 84 by 1.16 whole square is equal to 71 by 1 plus alpha. After calculation we will get alpha is equal to 0.137. परसेंटेज की बात करें ये 13.7% ये डिसोसिएट करेगा इन केस ऑफ परसेंटेज ऑफ अल्फा. आफ्टर द कैलकुलेशन विल गेट अल्फा वैल्यू 0.137. Up to this extent Cl2 will dissociate into the Cl atom. Next one. Now come to this question. In this question there are two vessels. In the left side vessel it's a mixture of 0.5 mole of CO and 0.5 mole of CO2. Actually these two vessels are actually connected with a tube of negligible length with a stopcock. Initially it is stopped. The second vessel is initially vacant. There is no gas in the second pot. It is opened for the some time. जो इन सम टाइम खोलेंगे बोथ गैस विल ट्राई टू एस्केप फ्रॉम हेयर. CO का मोलर मास क्या 28 है एंड द मॉलिक्यूलर मास ऑफ CO2 इज 44. द रेट ऑफ डिफ्यूजन CO इज मोर देन दैट ऑफ CO2. तो इस केस में क्या होगा, नंबर ऑफ मोल्स ऑफ CO मोर देन दैट ऑफ नंबर ऑफ मोल्स ऑफ CO2. बट नेचुरल है CO इज लाइटर देन CO2. The same time area of cross section is constant here and length is constant and time is constant. In that situation number of moles of CO will be more than that of CO2 in the second vessel. As per our question, number of moles of CO plus number of moles of CO2 is Z. Suppose X mole of CO and Y mole of CO2 has diffused, then X plus Y is equal to Z. It is given in our question कि एक्चुअली जो सेकेंड पार्ट ऑफ वेसल डिफ्यूज कर गया वो गैसियस मिक्सचर, तो टोटल मोल्स इज Z. In the mixture of second pot, both moles of CO and CO2 are present. No doubt moles of CO will be more than that of CO2 being lighter gas. ठीक है, just imagine X plus Y is equal to Z. In the next information ये कह रहा है M1 is the mean molar mass of the gas mixture that is diffused. इसमें जो आया इसका मोलर मास M1 है और इसका मोलर मास कह रहा है ये M2 है. तब देखो M1 मास क्या X plus Y, इसमें बचा हुआ कितना मोल्स रह गया CO का 0.5 माइनस X मोल हमारे CO रह गए, अब प्लस क्या है 0.5 माइनस Y मोल्स हमारा क्या हो गया CO2 इससे बचा रह गया, ये बचा रह गया. कम इन द केस ऑफ M1, दिस M1 इज इक्वल टू मोलर मास है किसका इस मिक्सचर का, तो X इंटू 28 फॉर CO प्लस Y इंटू 44 फॉर CO2, टोटल मोल्स इज X प्लस Y. X प्लस Y इज Z, इसलिए M1 इंटू Z इज इक्वल टू क्या होगा 28X प्लस 44Y. It's the second information. It's a second information. Now come to M2. What is M2? M2 is the mean molar mass of the first vessel mixture. M2 अब कितना रह गया बेटे 0.5 minus X mole of CO, it means 28 plus 0.5 माइनस y इंटू 44 बाय क्या होगा 0.5 माइनस x प्लस 0.5 माइनस y. This m2 is equal to 14 minus 28x plus 22 minus 44y whole divided by 1 minus x plus y. This m2 is equal to, now this m2 is equal to 36 minus 28x plus 44y whole divided by 1 minus z. Now m2 into 1 minus z is equal to 36 minus m1z. m1z plus m2 into 1 minus z is equal to 36. It is my experience कि एक्चुअली जब भी हम क्वेश्चन देते हैं द स्टूडेंट विल फिल इन सॉल्विंग द केस ऑफ मोलर मास ऑफ द मिक्सचर. मोलर मास में मिक्सचर में दोनों मोल्स हैं और CO and CO2 are non reactive, they are not going to react together. In that case हम क्या कर रहे हैं कि दोनों के कंट्रीब्यूशन है. तो पहले मोल्स दोनों में सेम था, लेकिन जब ये सेम टाइम एरिया क्रॉस सेक्शन कांस्टेंट, लेंथ ऑफ ट्यूब इज कांस्टेंट, एवरीथिंग इज कांस्टेंट, इट वाज वैकेंट इनिशियली. इस केस में मोल्स ऑफ CO वाज मोर देन CO2 being lighter, and x plus y total moles was Z, and mean molar mass of the second part of the gaseous mixture was M1, and M2 was the mean molar mass of the remaining gas which were present even in the first part. In that situation ये हमें प्रूव करना था, जो कि ऑलरेडी आई हैव प्रूव्ड इट.